I would now like to take a moment to introduce our second panel of distinguished members. First, Mr. Henry Green is the president of the National Institute of Building Sciences, and prior to this appointment, Mr. Green served as executive director of the Bureau of Construction Codes in the Michigan Department of Labor for more than 19 years. He was a founding member of the International Code Council Board of Directors, where he served as president. Ms. Helen Vaughn is the policy director for high-performance green buildings at the Environmental and Energy Study Institute, where she leads the high-performance green building initiative. She has authored or co-authored several articles, including Beyond Green, High-Performance Buildings, which was part of the fall 2009 edition of the MIT Press Journal called Innovations. Now, Ms. Lynn Bellinger is president of the American Society of Heating, Refrigerating, and Air Conditioning Engineers, and Ms. Bellinger is a partner with the Pathfinder Engineers and Architects, LLP, in Rochester, New York, and is ASHA's first female president in society's 116 years history.
About time.
And Mr. Bertrand is vice president of Delphi, where he also serves as president of Delphi's Automotive Holdings Group and Delphi Thermal Systems. And thank you so much for being here this morning. And as you know, it is required of us to ask you to stand and to take the oath. Okay. Okay. Do you solemnly swear to tell the truth, the whole truth, and nothing but the truth? Thank you. Let the record reflect that the witnesses answered in the affirmative. Okay. I would I'd like now to proceed first to Mr. Henry Green for your testimony. Excuse me, would you check your mic, please?
Okay, there we go. I apologize. Someone left a sign that says it's on. Okay.
Everybody lies around here.
We hope not. Starting over, I guess. Thank you very much this morning for allowing me to come in and testify on the state of high performance in green buildings in the federal sector. Congress established the National Institute of Building Sciences in 1974 as an authoritative national source to make findings and to advise the public and private sector on the use of building sciences and technology. The Institute's enabling legislation calls upon federal agencies to work with the Institute when appropriate. Through this engagement with public and private sectors, the Institute provides an unbiased focus on building science. The Energy Policy Act of 2005 called for the establishment of a high-performance building council within the Institute to look at the diversity of codes and standards and to determine the need for implementation of high-performance buildings. The council, with 70-plus private sector organizations, public agencies, produced a report in 2008 based on the 8 attributes of a high-performance building. These are sustainability, cost effectiveness, accessibility, productivity, historic preservation, aesthetics, functionality, and safety and security. These attributes reflect the definition of high-performance building and high-performance green building within the Energy Independence and Security Act of 2007. The definition also includes sustainability or green as one of the aspects of high-performance buildings. Federal agencies also have requirements that relate to high-performance buildings and attributes beyond energy, water, and sustainability. A sampling of such laws and executive orders includes the Americans with Disabilities Act, the National Historic Preservation Act, Public Buildings Act, National Environmental Policy Act, Executive Orders 13006 Historic Properties, 12977 Security Standards, and 12941 and 12699 on seismic safety. With numerous requirements impacting how federal buildings are designed, constructed, and maintained, achieving high performance is challenging, particularly given the complex interactions among these and other requirements. As High Performance Council reported, common metrics are needed to provide consistent, comparable measurements for the individual attributes and to understand and address the interactions across attributes. No single organization or profession has the knowledge or expertise to fully integrate the attributes into a clear path to high performance. But the High Performance Building Council, with its broad-based membership, can facilitate the coordination and cooperation needed to achieve delivery of high-performance buildings. However, since the completion of the initial report, resources have not been available to continue this effort. Once the metrics are identified and performance levels to reach high performance must be agreed upon, the underlying standards as well as research and development in both the societal and building sciences must be supported. Agencies have significant resident expertise on the individual aspects of high performance, but there is no single focal point for integration. The lack of integration should not be attributed to the agencies themselves, but to the fundamentals of the agency structure. Agencies generally focus on their key missions. Achieving high performance will require an integrated design, construction, and operation process that engages key professionals early on and throughout design and construction. The current budget process, with separate capital and operational budgets, is not conducive to this approach. The procurement process also tends to hamper collaboration. Most contractors and subcontractors are engaged after the initial building design is completed, so components and systems addressing high-performance attributes have been selected without their input and expertise. Some agencies have identified best practices and technologies and contribute to achieving high performance. These should also be shared and expanded. The Whole Building Design Guide, supported by 11 federal agencies, can serve as a repository for such case studies and validations. Several concepts have been, will assist in achieving federal high-performance buildings. Education and training of federal personnel engaged in the procurement, design, construction, and operation of federal buildings. Building information modeling to facilitate holistic approach to building design, construction, operation, and deconstruction through the building's life cycle. Total building commissioning upon completion of the building, retro commissioning, and periodic recommissioning. Utilization of integrated processes resulting in holistic and efficient approaches to meeting the numerous requirements placed on federal buildings. The Department of Homeland Security's high-performance-based design project within the Science and Technology Infrastructure and Geophysical Division illustrates how the range of attributes can be used in developing high-performance buildings. This project integrates blast protection, chemical, biological, and radiological protection, along with energy, sustainability, durability, air and water protection, and other major building requirements. With an integrated approach, high-performance buildings can be achieved. The structure to achieve this goal is partially in place, but there needs to be a sustained effort to bring about the collaboration and consistency essential to bring high-performance federal buildings to fruition. Thank you very much for this opportunity, and I look forward to your questions.
Good morning, and thank you, Chairwoman Watson, Ranking Member Bilbray, members of the subcommittee, and staff for this opportunity to present our views on federal green building progress and practices. I have a written statement for the record that I'd like to summarize in the slides that I hope you can see. My name is Ellen Vaughn, and I lead the Buildings Initiative at the Environmental and Energy Study Institute. This is a nonprofit policy education group here in Washington. High-performance green buildings are an essential part of EESI's mission to advance sustainable solutions to climate change and other critical issues. Slide 2 shows what we mean by a high-performance building. It is energy efficient at its core. It is green. It is energy efficient, green, and maybe it's a VA hospital that must deliver high performance in accessibility for disabled vets, lots of natural light and good indoor air quality to promote healing and well-being, and maybe it's in a historic building that must be preserved. Henry mentioned seismic standards. Certainly a green building destroyed by an earthquake is not sustainable. So all these things are achievable, but it requires a holistic approach to planning, designing, and retrofitting. If these goals were considered separately, as an afterthought, or not at all, they would not likely be achieved. Slide 3 shows the evolution of the legal framework and resources for creating energy-efficient, green, high-performance buildings in the public and private sectors. We're grateful to this committee for your leadership in putting the definition of high-performance buildings in the 2007 Energy Bill. This lays the foundation for the important work ahead in achieving high-performance buildings. Slide 4 discusses the shades of green again, in that federal agencies have been leading in every shade of green for years, and they continue to break the mold. A GSA border station for port of entry, for example, can it provide superior indoor air quality despite the exhaust from idling vehicles? Can it provide lots of view glass? Can it be energy efficient? Can it protect against security threats? And come in on budget? Yes, GSA has accomplished this by setting these and other performance goals at the beginning and throughout the project with each member of the team. In slide 5, this shows further evolution in federal building performance, and this requires government-wide performance targets and standards, consistent guidance, holistic planning, life cycle budgeting, a nonlinear integrated approach to design, and simple design tools. New capabilities for training with 3D virtual buildings make this possible like never before. Slide 6. Congress has shown leadership by requiring performance targets such as reduced energy consumption and the statutory authority for high-performance buildings. Congress can further enable federal buildings to lead by example by funding training, standards development, R&D, testing, demonstration, and information dissemination that is focused on high performance. And finally, in slide 7, federal agencies can rise to the challenge with the right resources. They already are making amazing progress in spite of stacks of requirements and FEMP's elimination of whole building training courses. We question who the ombudsman is or the coordinator for high performance. Is it FEMP or is it GSA? DOE's proposed rulemaking on sustainable design is a great thing to see. It folds in the executive order and the MOU on sustainable building principles. So why doesn't it address fossil fuel reduction requirements at the same time? They are connected. Renewable energy supply needs must be determined. Federal procurement will help drive the market for renewable energy production in this country. International high-performance building standards, such as German Passive House and the Swiss Minergie, should be studied and utilized. Federal procurement of high-performance green materials, innovative technologies, and best practices in design services will stimulate the market for better buildings nationwide. What green building pioneers have started, federal agencies can propel toward a revolution in the building industry like we have seen in electronics and communications. Thank you, and I'm happy to answer any questions.
Chairwoman Watson, Ranking Member Bilbray, and members of the subcommittee, thank you for the opportunity to speak to you today about standards and opportunities for the federal government to optimize building efficiency. My name is Lynn Bellinger, and I am president of ASHRAE, an international engineering society of over 52,000 members in more than 140 countries. Our members represent the breadth of professionals involved in the built environment, from consulting engineers and architects to manufacturers' representatives and academics. ASHRAE fulfills its mission to serve humanity and promote a sustainable world through research, standards writing, publishing, and continuing education. We are the acknowledged experts on energy in buildings and indoor environmental quality. The purpose of today's hearing is to examine the federal government's role in greening buildings. ASHRAE has long partnered with the federal government on this very issue, working to reduce energy waste while developing and consistently improving energy efficiency standards and advanced design guidance. In the 1970s, during this nation's first modern energy crisis, the federal government approached ASHRAE to develop a standard to address the energy use of buildings. This standard became ASHRAE Standard 90.1, which now serves as a federal building standard. Through the High Performance Building Congressional Caucus Coalition, ASHRAE has taken the lead role in raising awareness of high-performing buildings in Congress. Over the past 2 years, the coalition has held 27 briefings for federal policymakers on a wide range of building-related issues. My presidential theme is modeling a sustainable world. Building modeling represents one of the most powerful tools for optimizing building performance. And to exploit the full capability of modeling tools, we must transform our design approach from a sequential process, where one discipline completes its work and hands off the design to the next, to an integrated building design process, where all of the disciplines involved in the building design and construction work as a team from the beginning to evaluate options and optimize building design. Our biggest challenge is implementing integrated design in daily practice. It's going to require a cultural shift in our industry to transform the design process, and it's a shift that has to occur if we're going to reach our goal of net zero energy buildings. To accelerate this cultural shift, we recommend creating a new demonstration program with selected geographically diverse federal buildings. Earlier this year, in partnership with USGBC and the Illuminating Engineering Society, ASHRAE published Standard 189.1, the first code-intended commercial green building standard in the United States. Standard 189.1 serves as a compliance path of the International Green Construction Code, published by the International Code Council. Standard 189.1 is a game changer in building standards, and ASHRAE recommends authorizing a pilot program with a select group of geographically diverse federal buildings to examine the effects of requiring all new federal buildings to meet the IGCC by 2020 and include ASHRAE Standard 189.1 as a compliance path. This will help the federal government meet the objectives of Executive Order 13514 of ensuring that beginning in 2020, all new federal buildings are designed to achieve zero net energy by 2030. In addition to Standards 90.1 and 189.1, ASHRAE has design tools and initiatives targeted for enhanced building performance, including certification programs and advanced energy design guides. ASHRAE also has developed a building energy labeling program, which clearly shows tenants, building owners, and others the difference between as designed and in operation building energy use, and includes an energy assessment with recommendations for increasing energy efficiency. Congress can help close the gap between the designed and operational energy use of federal buildings by requiring all new and existing federal buildings to put in place within 3 years an energy performance information program that identifies both designed and in-operation performance. Understanding where energy is used in a building is the first step in reducing energy consumption. In closing, significant progress has been made over the years in the federal, commercial, and residential sectors, and we are poised to embark on a new era of energy efficiency and taxpayer dollar stewardship that will lead us to net zero energy buildings. Much work remains to achieve that goal, and as a national and world leader in developing building standards, ASHRAE looks forward to opportunities for working with Congress and the executive agencies as we all move toward a more sustainable tomorrow. Thank you again for the opportunity to address this subcommittee, and feel free to contact me or our DC office if you have any additional questions.
Thank you, Ms. Bellinger, and Mr. Bertrand, you may proceed.
Good morning, Chairwoman Watson and Ranking Member Bill Bray. I'm Jim Bertrand, and as President of Delphi Thermal Systems,
Thank you.
I'm Jim Bertrand, and as President of Delphi Thermal Systems, I'm pleased to be a part of this panel, raising awareness and creating focus on the great opportunities for energy savings in our federal buildings and installations. I recognize that implementing the policies and regulations that will govern these reforms presents a significant challenge. We at Delphi want to be part of that dialogue that is used to resolve these questions because we think that we have technology that can solve some of the problems. We are also pleased to share our experiences in presenting our technology to the federal government. We hope that we can provide insights to help improve regulations and policies. Delphi is widely known as an auto parts manufacturer, but the reality is that we are a technology company. We hold over 7,000 patents, and while most of our intellectual property is utilized by automotive manufacturers, there are many non-automotive applications for our technology. One example is our microchannel heat exchanger technology, which has proven successful in both automotive and non-automotive markets. The microchannel heat exchanger has the potential to provide improved energy efficiency and reduce the impact on the environment because it is smaller, lighter, uses less refrigerant, and is able to achieve higher energy efficient ratings. If we replaced one aging heat exchanger in each of the 500,000 federal buildings, there would be 4 immediate benefits. First, 5 to 10 million less pounds of refrigerant in the atmosphere, 10 million fewer pounds of materials, mostly imported copper, more energy efficient optimized heating and cooling systems in reduced spaces, and lastly, energy savings of up to 25 to 30% over traditional AC units with lower ratings. Delphi has sought to offer this solution to the federal government. However, our experience is that the federal effort is focused on achieving building-wide reductions in efficiencies. We applaud this focus, but at the same time, this focus should not come at the cost of incremental but significant gains in efficiency. Better focusing on building components could result in some dramatic results. But from our view, the efforts to date have not yielded powerful enough incentives to accelerate the adoption of innovative green components in federal buildings. Despite these challenges, there are some things that can be done to improve the situation. First, establish incentives for the implementation of energy-efficient components. For example, Delphi is supportive of a provision of the Homestar legislation that establishes powerful additional incentives for homeowners who choose to implement the highest available SEER standards, 18 SEER. Is there an opportunity to create comparable incentives for buildings that are owned or leased by the federal government? The U.S. Green Building Council has also identified existing authority for DOE and the GSA to improve performance standards applicable to federal buildings and leases. Second, examine opportunities for federal procurement reform. Delphi is supportive of elements of legislation that improves federal procurement of energy-efficient building technology, such as Senator Carper's Improving Federal Use of Renewable Energy and Energy Efficiency Act of 2010. Delphi supports better measurement and data collection to assist in federal energy efforts. We also believe greater flexibility is needed in procurement requirements for federal building projects facing long delays. Technology is changing quickly, and this flexibility allows for the adoption of the best and newest technologies. Third, consider pilot programs to test and analyze retrofit performance. We believe that a pilot program examining implementation costs of retrofits, as well as the short-term and long-term efficiencies and savings of technology upgrades, would be helpful in guiding federal efforts to select energy-efficient technologies. We respectfully recommend that the pilot program should examine technology components. In conclusion, we have already stated that reducing energy consumption is an extremely hard challenge, and we are no experts in creating guidelines like organizations such as the United States Green Building Council. But we do believe that the tools that are at the government's disposal have not been used in a way to encourage rapid adoption of components like our technology that can help the government achieve its goal of greener federal buildings. We are honored to be on this panel and look forward to being part of the continuing dialogue. Thank you, and we look forward to taking any questions you may have.
Thank you. I'd like to thank all the members of the panel for your testimony today. And we're now going to move to the question period and proceed under the 5-minute rule. But I want to remark on the testimony, Ms. Vaughn, that you made. You know, I was thinking, and you had your slides up, and you said, you know, green buildings and so on. And I thought about airports, and California was the first state in the union to ban smoking on airlines, and now it's global. But you come out of the airports, and the first breath of air is all of that smoke that gets captured under the eaves because people are taking their last smoke before going in or their first coming out. And so I would hope that when we talk about green buildings that we would attach and adjacent environments, because I think that you're tremendously at risk when the first breath outside is filled with toxic smoke. And the last breath going in, you got it in your lungs, and it settles there for you the whole time you're inside. So I just had to throw that out, and it occurred to me when you made your testimony, all of you are offering us valuable input as to how we need to proceed from here. And we're talking about prospectively, but we're talking about retrofitting what we have now, and we're keeping in mind the cost. And, you know, we have this huge deficit that people are harking at all the time. But there's certain things we need to do now to guarantee the health of people in this country and those coming into this country. And so we're trying to balance between that. But I just wanted to reflect on the testimony that was made. So I'm going to ask all of you, would you please define the zero net energy, and to what extent has the physical comfort of human beings been considered in the movement towards zero net energy usage? And I'll start with you, Mr. Green, please. Thank you, Madam Chairwoman.
As I noted in my testimony, the work to do this or to accomplish this is very broad-based. There are a whole number of attributes that have to be looked at in that respect. So when we start looking at the indoor air quality, for example, how we look at achieving zero energy, there's a balance between all the components that are there. So it's going to take not only both the scientific research to get there, but it's also going to talk about human behavior and how we in fact achieve better human behavior in the buildings that we're in. As you noted, once we stop people smoking in the building, the first thing to do is go outside of the building and start smoking. So what we have to do is we have to talk about how do we affect that behavior as well? How do we impact how we use our buildings? How do we impact the future of our buildings by achieving greater utilization today, even in existing buildings? And I think that's part of the difficulty. So your question is, what do we define as zero energy? Zero energy can take on a whole number of different definitions. And I think that the industry, as very broad-based as it is, must come together and also help define what zero energy is. And does it start at the supply? Does it start at the building? Where does it start initially, and then where does it end? And how can we gather all the data necessary that we can make that achievement known? The metrics to get there have to be defined, and also the level of performance. So what we have to do is there is a very long path to follow to get there. So I know I'm not answering your question specifically. I'm just trying to lay the groundwork that there is more work that needs to be done to say, how do we achieve
Get
zero?
us thinking.
Yes.
Yes, Ms. Vaughn?
Yes, thank you. Yes, there are several different definitions. One of the working definitions of net zero energy is that first you reduce the energy load as much as possible. So your building, it's a low energy building, and it uses only as much energy per year as it can produce on site from renewable sources. That's one working definition. But there are others as well. And how to balance energy efficiency and indoor air quality. We have some fine engineers in the room who are working hard on these things. We have standards like ASHRAE 62. And one of the things that we learned, I think, it's a very good question, you know, back after the 70s when there was a focus on really tightening up buildings, some people forgot that there was an indoor air quality issue if we did that. So there's been a lot of learning and adjusting, and I think a lot of progress in balancing the two, and it is that trade-off that's so key. I would just refer quickly to Passive House, and again, if we can learn, you know, study these best practices and these examples. Passive House in Germany, it's a standard that can reduce energy use to the point where they don't even need a furnace, or improve the building envelope. It's a very focus on high insulation levels. But they have this constant air exchange, and there's, you know, different concerns about how that could work in a hot, humid climate, but people are working on this, so I'm hopeful.
Thank you. Ms. Volunteer.
Yes, before I address the current question, I want to respond to your first question about smoking outside airports and public buildings. One of the provisions in ASHRAE Standard 189.1 is prohibiting smoking within 25 feet of an entrance, and there needs to be signage on the building to indicate that. So that's a recognized problem, that you don't want people jumping outside the building and smoking immediately, and that's addressed in that standard. The definition Ms. Vaughn gave for net zero energy buildings is really what we've been using. As Henry noted, there are a lot of different ways to define it. The building owner sees the utility bill, so we're looking at site energy and using a definition of net zero buildings as those that use no more energy on an annual basis than they can produce on site. So that's consistent with what Ms. Vaughn just said. And within Standard 189.1, there is a requirement to comply with two other ASHRAE standards. ASHRAE has Standard 62.1, which is a ventilation standard, and you must comply with the ventilation rates that are required within that standard for the various types of building occupancy in order to comply with 189.1. So you can't avoid bringing in the outside air or the proper amount of ventilation. Another standard that we have is Standard 55, which is a standard for thermal comfort, and 189.1 also requires that you comply with Standard 55. So it's very much looking at the indoor environmental quality as part of doing a high-performance green building.
Thank you. Mr. Burch.
Yes, Chairwoman Watson, at Delphi as an HVAC component supplier, our efforts relative to zero net energy have really focused at the component level and are very much geared towards the development of devices that have minimal impact on the environment. The microchannel technology that I had in my testimony that I referred to is a good example of that, a device that obviously minimizes to the maximum extent possible energy consumption and minimizing environmental impact. So that's really the field of play that we have in the debate.
Thank you.
Thank
I
you.
now recognize Mr. Bilbray, our ranking member.
Thank you. Just for the record, I want to assure everybody, but California will not have a problem of people smoking outside the way it's going. We are going to outlaw all public smoking in the state of California, at least public smoking of tobacco, okay? Why do people think I'm joking when I say that? I'll put you on an airplane and send you back to Sacramento. And it is interesting to hearing this discussion because we all know that indoor air is a major air pollution issue down the line. Not to make you think that I'm some kind of 70s hippies, but I actually own an adobe house. But I know my wife, who's from New Orleans, always said she came all the way across the country to live in a mud house. Now, I imagine what our radon numbers are, but it's a good thing that Southern California is not a high radon area. And you remember how we've done that. We sealed up in the 70s, and by the 80s, the one crisis on energy was curtailed, and then we had the radon exposure was the next crisis. And so we kind of go through these series. I want to sort of get around to how we get to this practical application. Mr. Bertrand, you're talking about subcomponents, which really could add up. A good example, I guess, what you're doing is with the electronic aspect on reducing energy consumption. What I need to do more of in my adobe house, and that is go around and seal up all those little cracks that over 100 years have steadily widened. But you're doing it from an electronic point of view, the component. Seems like, though, that our system, and I'll say this, go back and forth, our system would not be able to accommodate your improvement because we're looking more at the total refrigeration unit or air conditioning unit, not a component that could be plugged into it. Have you run into that problem with our federal process?
I think, to be fair, we could use more clarity on directing our efforts. What we have encountered, as I mentioned, is there's an emphasis on the total building system. There's a lot of energy around, obviously, the new standards for new buildings, but the question of how do we bring innovation to the existing fleet of buildings that we have is one that we think deserves more attention, and one where maybe we don't need to paint such grandiose pictures. We should go after implementation of, there was earlier testimony around how many off-the-shelf technologies there are. Certainly we have some, other companies have them. There are many opportunities out there for us to make a significant improvement in the efficiency of the federal infrastructure.
Those small steps make a lot of difference. And
right.
To paraphrase the Democratic Party, the way you eat an elephant is one small bite at a time. Ms. Bellinger, do we have the ability, seeing that we're not going over to Home Depot and pulling an air conditioner off the shelf and sticking it in as much as some people might think. We're actually designing, engineering, not just the building, but even the electronic components, the refrigeration. Anybody here want to comment on that? And about the ability for us to integrate and look at, get the expertise. Do we have the ability to tap into the expertise to know that these improved components may be out there and may be incorporated into our next big building that we look at? Do we have that capability in-house, or do we have the ability to contract that capability to make sure that the finished product, is that part of the contracts we do when we go to the engineering side, we go to the design side?
Mr. Bilbrey, you certainly have the capability of doing it. The difficulty, I think, today in the way buildings are procured don't facilitate that kind of collaboration. The problem today is that on one hand you have a design component that designs a building. There are design engineers that are engaged in the design of the subsystems and the total building system. Architectural engineering, which includes mechanical, plumbing, etc. They design a building based upon their best practice or their understanding. They may not reach out as broadly as going to a manufacturer of components to determine exactly what's new in the marketplace. Now, once the building is designed and it's been approved, it's started construction, and you can't go back and change when you find that there's something new or innovative that you could include in the building. Because now we have a set of design documents that you have a bid process that said, here's what you're going to build and here's what you're going to get. The capability of doing this is to go back to a systems approach and then doing what we would call an approach to design that is by not specification but performance, allowing the performance factors to determine how the building is designed, and making it and incentivizing during the construction process if there is in fact a way to change the project from its design in the construction process that would yield additional savings and or better performance. And again, based upon performance, not specification.
Right, and that's what, outcome-based, let me just tell you something. all the time I've been frustrated with environmental strategies or whatever is that when the federal government goes to process-based instead of outcome-based, one of the things I'm very, very proud of as a Californian is so much of our environmental programs are successful, like our Clean Air, like our Clean Ocean Plan, is that unlike the feds that like the Clean Water Act, which are process-based, outcome-based is truly the environmental step. It's an evolutionary step beyond that. But before I leave, let me just say, ask for your indulgence. I'd like to get down to one issue that we need to address. We may talk about these components, but one thing I learned at the Air Resources Board in California was before we allowed somebody to transfer a component into an automobile, even selling aftermarket, we prove longevity. And before I leave that analogy, I'm going to say one thing. Just as we forced the auto industry to go from carburetors to injectors, though they didn't want to, but to come up to the efficiency of clean and mileage, they had to go to a different technology. We need to put the same pressures on ourselves to kind of force us to be on our game. But when it comes down to longevity, when you take one of these components, let's just say you do have an efficient one, are we doing the testing, and how do we make sure that a unit is not just effective the day you buy it, but over 5, 10, 15 years, because there's where you will find marked difference in certain type of technologies. And we've run into that in the air emissions issue with automobiles, where we literally had to outlaw products that looked good when you first bought them, but became major environmental problems later. Do we have that strategy when it comes to this kind of efficiency, like the STAR program?
The other panel's members may want to comment further on the details on the procurement process. The nature of our products some of them can decay in terms of performance over time. So, Congressman, you're on to a very real issue, which is the efficiency at a component level at the start of the life versus later on, and looking at that total life cycle cost development, I believe, is a very important aspect, and should be, if it isn't strongly featured in the entire government procurement process, as you would look to put precious taxpayer dollars to work to make sure the components we are putting in have the sustainability and will hold up over time and still deliver that performance level.
In fact, Madam Chair, I appreciate giving me the time. I'd like to make a statement. I sure hope somebody is listening about this. Of all the years working on environmental oversight stuff, I'll bring a little street knowledge to you. I believe the E-STAR program needs to move on, needs to become more more effective. I believe that there should be an E-STAR standard that starts off with the initial efficiency that we use today. But there ought to be longer-term ratings to where we have 2 or 3 or 4 numbers, so people understand that this product is very effective today. It'll be effective in 2 years. It'll be effective in 10. But at 12, there's going to be major problems. And that the consumer knows that because we have done the testing. And that may seem like a whole big drawn-out thing, but let me tell you something. Every aftermarket product that is sold in this country goes through that for automobiles. It's time we take a look at the same thing when we talk about efficiency. So those numbers, that E-STAR, really means something beyond just how well something works today. And that means that we've got to do the research, because I think all of us agree we're doing things to try to save this planet and trying to do it quickly and effectively, but where it really is going to pay off is the cumulative impact as long as the technology continues to operate. If it doesn't, everything we're doing is really for show. Thank you very much.
As you have just heard in the ranking member's comments, this is a burgeoning area of concern to our federal government. And those of us who have worked at local government and state government have been challenged by these issues, particularly those of us on the West Coast. So this is just the beginning of this dialogue that we will be having, and technologies are being invented every single day that must be taken into consideration as we go for green building. So thanks to all of the witnesses. Your input goes into the record. And Mr. Ranking Member, without objection, I would like to also thank the other members that were here, but without objection, we'll adjourn this meeting.